So plan for today is कि हमें एक म्यूज़िक विजुलाइजर बनाना है एंड इट इज़ गोइंग टू बी सी प्रोजेक्ट C++ प्रोजेक्ट जहाँ पे हम हमारे डेस्कटॉप का ऑडियो बफर को हम लाइक रीड करेंगे एंड उसको प्रोसेस करेंगे एंड उसके अकॉर्डिंग हम एक विंडो बनाएंगे जिसमें हम विजुलाइजेशन दिखाएंगे. सो टू गेट स्टार्टेड हमें एक CMake list .text फाइल बनानी पड़ेगी जहाँ पे हम हमारा प्रोजेक्ट कॉन्फ़िगर करेंगे विद ऑल इट्स डिपेंडेंसीज. सो हम सिंपल ChatGPT का यूज़ कर सकते हैं टू जनरेट अ सिंपल CMake फाइल फॉर अ C++ प्रोजेक्ट. सो लेट्स डू दैट. सो बेसिकली हियर आई एम आस्किंग कि मुझे CMake प्रोजेक्ट बनाना है और मैं जनरली आई प्रेफर पैकेज कॉन्फ़िग यूज़ करता हूँ ताकि मैं सिस्टम में ग्लोबली अपनी लाइब्रेरीज इंस्टॉल कर सकूँ एंड यूजिंग पैकेज कॉन्फ़िग आई विल फाइंड देयर लाइक इंक्लूड पाथ लाइब्रेरीज एंड उसको मैं अपने एग्जीक्यूटिव में इंक्लूड कर सकूँ. अपार्ट फ्रॉम दैट आई लाइक टू एक्सपोर्ट कंपाइल कमांड्स ऑफ JSON. दिस इज़ जस्ट प्योरली फॉर LSP पर्पसेस सो दैट आई हैव गुड ऑटो कंप्लीट जब मैं न्यू वगैरह यूज़ करूँ. एंड आई थिंक लास्ट इज़ आई एम जस्ट एडिंग अ रूल सो दैट जितनी भी सोर्स में हमारी CPP फाइल्स होंगी वो ऑटोमेटिकली हमारे सोर्स के पाथ में ऐड हो जाएगी. सो लेट्स जस्ट कॉपी दिस. Let's have something recent and we'll change it. Project and okay, that's fine. Let's import Raylib this way. Let's ignore it for now. I like to name my class as .cc. Executable name would be audio visualizer. Same here, no need for this right now, and let's move this a little bit up. Okay. Now let's create this thing. So I'll create a directory which is so source. I'll create a file here, main.cc. Hash include IO stream int main return 0. Okay, let's create a script for this so that we can build this file very fast. Okay. Yeah, so we'll name it build and run.sh. let's create a shebang here, bin sh, and what I like to do. So yeah, so I'll rmrf the build folder. Let's not do that. CMake build source and then CMake build. One thing that we can optimize for is that just run the command if the last command has successfully ran. So like we can just search bash to check if last command ran successfully. Mm-hmm. Okay, let's use this. Da-da-da. Come on, format. Okay, so this means that this is successfully. So in that point, I want to just build it. CMake build and build, and also I would like to link my compile.json. So compile commands.json to compile commands.json. Okay, and this time I don't want to do anything else. Yeah. So okay, let's create new pane. Not this. Is this? Okay. So CV recording, audio visualizer. We need to make this thing as executable. So let's do that. Then build sh, then run this. Or before that, build and run sh. Yep. Now let's also run this thing. So we'll do the same thing again. If this thing runs successfully, then we are just going to run this. So that would be build and our file name. Let's try that again. See this. Okay, so let's open our MC file. Let's try to print something here. So string C out hello world. Yep. So simple project setup is done. Next thing, okay, what's next thing that we can do is try to add the dependency on Pipewire that we are going to use for actually reading the frames. So let's look that up. So I've already installed, I think, Pipewire, so just checking it again. Okay, so spelling mistake. Oh, it's already installed, so nothing to do. So what can I do next is I try to find if it's there. So I'll just try to find it. Also increase the font size a bit. RG files, I want to look for an user blip so that I have it or not, and I'm searching for Pipewire. Okay, Pipewire is there, and I want to look for something called a PC file that will let me know if I can use package config to search for it or not. So pipewire.star, and if it ends with PC, yeah, so it ends with the PC file, so we should be able to use this thing to actually have it. Okay, so let's do that now. CMake, okay, call it Pipewire. So we have it as named as Pipewire 4.3, and we'll add this. Okay. Now let's try to find an example command for Pipewire. Pipewire API CPP. Okay, let's try it on GitHub. Okay, so let's try to find the file. tutorial. Okay, we have it here. So yeah, this is the example code that should work if we have included the Pipewire correctly. So let's just copy this main.cc. So yeah, Pipewire 03 is not found. Let's try to change the name, I guess. Maybe it's just Pipewire. Let's search. Another thing that I think we can try is package config Pipewire libs. So we are looking for, I think, lib and us 0.3. Cool. And are there any C flags? So we need to have in C flags as well. Okay, first do this lib Pipewire 0.3 and let's open a new tab and ChatGPT. Snake package config how to get C flags. Include bars. Library. Include dash. Okay, cool. Makes sense. So I'll just do this. Include directories and pass in let's see, does it work? Okay, so we have compiled, we have linked. Okay, so this is the output that we got, and what was our main.cc? Yeah. Does this work? Yeah, it does work. Oh no. Pressing the wrong key. Now let's look for a better example for Pipewire. Pipewire GitHub. Look for audio capture. So this is the example command for Pipewire. What is it doing? They have a data object. Probably they are using it as a context. Okay, this is the data processing part. They get a buffer from Pipewire. They do whatever they want with the buffer, and then they give the buffer back. Okay. So this is that part. Be notified when the stream param changed. We are only for format changes. Okay, so what does it mean? Okay, so just that format of the stream changes, then they will get a callback, and the callback is on void start data, which is, I think, yeah, the same object data. So yeah, this is definitely the context pattern that C classes uses, because they don't have access to this class and objects, right? So they have only free functions, and whatever like context or state they need to maintain, they use to create a void star pointer for that, and these objects are passed around to these free functions. Okay, so we might need to create a wrapper for this since we are working in C++ and we want to use class and objects. Okay, so anyway, back to the point. So there's a callback for stream parameter change, there's a callback for processing the buffer. What else? These are attaching those events. Do quit struct data, again same, do it's a user data as the first parameter, seems like a callback. This is the callback for quitting the loop. Okay, no, main. Okay, so creating the initial context objects, creating other objects. This is the buffer size that we want to set. Okay, we can configure the buffer. We initialize the library. We are creating a loop. Add signal. Okay, if we press Ctrl C or something, we need to get out of this loop. Got it. Okay, just setting up the properties for the stream. Seems like the metadata. ठीक है. Okay, so what to capture audio from? Iska is from command line we want. If it, okay, create the stream and okay, so basically capturing the stream type, and finally we are connecting the stream here. Okay, cool, and wait for the things to run. So yeah, okay, and we're destroying everything. So basically this is the blocking. So we don't need a while running loop, while true loop. This thing will block until I think we press Ctrl C. So yeah, this Pipewire is coming with its own while loop. We need to figure out how we can work with this when we will introduce like our own while loop, because we want to have this on separate threads. Like UI का काम UI thread पे होना चाहिए, and ये processing का काम अपनी खुद की thread पे होगा. तो yeah, okay. Let's just copy this entire example first and let's see if it works. Copy. Oh, okay, copy again. Errors. This is fine. Cannot initialize data. Struct data star with the val value of void star. Okay, yeah. Obviously, we have a void star and we are trying to convert into struct data star. So, yeah, I think static cast is into struct data star. So. Underscore. So let's copy this, and probably we need to use this all other places were like this. Next. Yeah, no other place. Cool. What else? Same problem. Static cast to float star, and just this part. What else? Same problem. Static cast struct data star and got this. Next. Warning, we don't care about warnings. Taking the address for temporary object. Yeah, move it out. this like this. Take the address here. Next, what? Matching function. So what is this function? What do you expect? You want a stream, you want enum, you want target ID, you want enum again, and what are we doing here? This matches, this also matches, this is just number, raw number, that's fine. Yeah, okay, enum flags, but internally they are integer, so probably we might need to do another static cast. PW stream flags. Okay, so let's do this. Static cast enum PW stream flags and do this on all of them. Okay, next warning. Yeah, nothing there. Let's try to build and run this. Hello. Okay, so basically we can see that like the star is going somewhere, right? Because there's audio. So so audio capture works, but unfortunately I think it is picking up my headphone. Okay, anyway, that's fine. So okay, got it. Let's play some music while we are here. Copyright, free music. Come on, let's do this. This works. Okay, so next thing, let's try to create a wrapper around this audio stream. So let's do one thing. Let's move this entire thing. Okay, so let's rename this to main.backup.cc and let's create another file, main.cc. So main.cc we have opened, and if you look at this, come on, and here we open main.backup.cc. we have, okay, so here we are going to delete everything. Let's just include IO stream because I'm comfortable when we import this. Int main, and yeah, okay. So the plan of action is let's create an audio stream object. So audio stream, and this thing is going to take the source name. So right now, for example, Google Chrome is playing, so we just say Google Chrome, and we need to give it some sort of callback that will be executed when there are buffer, and yeah, that's it. And we should be able to start the audio stream, and we should be able to stop the audio stream. So this is what I want, because once we have the graphics library, I want that to manage when we are going to start and stop. So if the window is running properly, we should sample audio, visualize it. Once we request video to the window to close, graphics window, we should stop the audio stream as well. So with this API we can have that easily. Yeah. So let's assume this. Let's create this file, audio stream.h, namespace visualizer should work. So class is audio stream, and yeah. So now members. So the ones you already decided, let's go for that at least. So we should have an on start. We have on end. Not on start, not in event. So let's stop this. How about a private method, private things? Let's write strings for now. So standard string, source name. We need a callback as well. So let's define what callback is going to be look like. So it could be a function that is going to return void, but is going to receive a vector of frequencies. So that's going to be float, and yeah. So let's name it as frequency callback. Okay. Make sure this works. Okay, so let's have this frequency callback reference to our callback processing function. Frequency callback. Okay. Yeah, sure, define. Okay. So this works. Now next thing is the main thing that we need to deal with are the callback functions inside the Pipewire library. So what they do is they have a context object, right? So here's what happening here. So yeah, so there are like list of this Pipewire functions, and they take this context object, everyone, and then their own arguments, and they take this context, they perform any action they want, and if there is any change in the context, they change the context, return it back, and so basically they update the context itself. And this context is the pointer. It's a void star pointer. So that the main reason iska void star pointer hone ka is because void star pointer can then be like at runtime can be converted into any other pointer. So you can store any sort of data in this. So we are not limited by the structure. So this allows us to pass our own structure. Now, when working with C++, we don't need all of this, because when we pass around objects, हमारे पास for each object there's unique variables that we can store as member variables and member functions. So we don't need to do all this. But while using this C library functions, right, there are scenarios when we need to pass them as a callback functions here. And limitations with C++ is if I write something like, so we have this function called on process, right? Suppose मुझे चाहिए कि on process run हो with the buffer data that we have. And I want to give this function to this underlying C library. Problem ये कि this function on process is audio stream का member function. मैं इसको without the object access नहीं कर सकता unless I make it static. But if I make it static, वो function is going to be common in all my audio stream classes. So if there's only one audio stream in your program, yeah, sure, do that. Your thing will work. But we want to be able to have multiple audio streams and multiple callbacks. So anyway, I think one good way of doing this is, since we have this void star, that can be anything, right? So we can pass the pointer to the audio stream object itself. That would be our context, or void star in this case. And callbacks are going to be the free function. And inside the free function, what we are going to do is so this would be my audio stream, and inside the free function I can do that a stream dot then actual function I can call, yeah, and this audio stream will already have all the context that we need to work on it. So yeah, this is the idea that we have. We are working on one assumptions that, for example, if we are going to have pointers that are going to be needed by the library, they're not going to change by the library itself, and generally वो change नहीं होता unless we might need to, and so we should be fine. But अगर change होता है in some scenario, I cannot think of it, वो अगर होता है तो we need to create a बड़ा context object that has all the dependent data that can change, and an object to our audio stream object as well. But yeah, we will cross that bridge when we'll get there, so let's not worry about that right now. Okay, so let me just start coding, and once we have some code, I think it would be easier to understand. Okay, yeah, so I think let's assume that void star it's just going to be an audio stream on start on process. I'll add this later once we have that. So let's write the implementation for this thing. Audio here, audio stream.cc, and yeah. So what do we have? We don't need this, and let's add this. Okay, let's have another empty namespace because you're going to need it later. Audio stream is not found. That's fine because you haven't included it. Include audio stream.h. Yeah, okay, so before we do this implementation, we need to fix our CMake file. Okay, so right now it's picking only this. So let's have headers, and in our include directory, let's do this headers. So it will automatically include all the headers in our source file, so we don't have to worry about it. Okay, so just quickly check. Yeah, so connection works. Now let's go back to our this thing. Suppose we are in main, right? So this is our context object, and we are inserting data in this. So we are adding loop here, we are adding stream here, and yeah, stream and loop. So let's look at the type. So basically this was in the context, so all of this thing I also need in my class as well. So let me do this one thing. I'll just create all this and I'll create an internal nested struct. Let's call it context, and it will have all those things. Okay, and I'll have a context object. Context. Let's make it a unique pointer since we're going to be passing it around. Unique pointer, and it's of the type context. And now we need to initialize it as well. So context we're going to initialize, and let's create a function to do that. So create context is going to be called. So let me clear it here. So standard it would be create context. Okay. Okay, we'll deal with this later. PW stream, let's include this, and let's include this. Okay. Where did we pick it up from, man? Backup struct audio info. Oh, this audio info. So next is okay. This thing is ready. Let's create the setting context object first, because it seems to be like the one doing the heavy lifting. So same, it's from audio stream, shift P and create it. So I'll create a context object, and it's going to be make unique and text. And I'm going to return that context. Let's have them some here. Okay. It would be audio stream. Okay. Namespace issue. So we are calling it visualizer, and once we need to include it audio stream. Frequency callback. So let's create a static function for now. Static. Frequency buffer. This is going to take our frequency callback and we audio stream dot frequency. Oh, we cannot. Unique pointer to standard vector float. Oh, it's a reference, so we need a reference to stand function who returns void and take a vector of float. Okay, so there is no unique pointer here, so delete till this and does this thing need to be a const? Yeah, when in doubt, ChatGPT. ChatGPT static function to a standard function in CPP. Okay, so this is our function, this is the type, and they passed it as lambda y. Okay, let's try that. Anyway, we're going to need lambda later, so let's do it right away. Oh man, I really hate standard functions. Telling me the other thing, man. Non-const al value reference of type this. Hey, I changed it from reference to something else already. This is the issue. Cool. This is just a backup shit problem, so main.back.cc should be source main.backup. Yeah. Okay. So cool. We are building this. Now what? So let's focus on creating the context. So we need to fill this up. So we need to fill all these values from the example. Okay, no problem. So I think it's happening in main. So we go to main. We copy this entire thing before we actually start the stream. What is this? Do we need this? This loop params are used for connecting to the stream. Are they used? No, they're not used. We'll, I think, do it till here. Even props are only used. Okay, let's copy. We'll deal with later what need to go where. So let's create the context. We don't need data because that would be our context. Okay. Wave as incomplete. Spa pod builder. We don't have this. Let's do null pointer for now. Include this next error data.loop. So this will be our context dot this. Next. So Okay, we'll deal with the context later. And PW. Okay, so wherever we're passing data, we need to pass, I think, so this is address of data, right? So just part this, change to this, and change to this. So yeah, our audio stream object is going to be our context thing. Next what? Props undefined user one declare identifier, where it is. Oh, we have it here. No, not there. Confusing. Somehow missed this line. That's fine. We need to set this as a string, so that would be our source. What source name, right? Source name, and then this would be context. This one props is fine. Stream events. What is this? CF. Stream events. Oh, you have created a const thingy. Okay, this is something which is anyway unique. Okay, cool. That's fine. We think we can have it. Now namespace for now. We need to create these free functions later. That's fine. Yeah. So this is state changed, and okay, let's copy it from there. So this is our on process and on stream param changed. Both of them we need, and we need this as well. So let's copy it right away. And main dots or main audio. Okay, before we do that, let's create the appropriate versions. We need on process void Okay, and this is going, since we passed this, so all of this is going to be audio stream pointer. Let's change. Audio stream, and we are going to call audio stream dot on process on this, and we can forget about all this for now. We need to do this on stream as well. So yeah. So this is going to be yes, and we can pass rest of things. So you want 32 and id comma param stream. Okay, so let's add this to function, but we don't need first thing. Okay, what else? This is fine. Do quit. So yeah, we're going to just do the same thing here. And signal number and okay. So what I did is when we whatever callbacks that he had, and I'm just passing the actual audio stream object, and on that object I'm calling the member function version of it with the params that we got. Okay, so now let's move all this thing and we need to do this. Okay, so on process should take care of all this, and what about on stream? On stream should take care of all this. quit. On quit, need to do this. Okay, let's fix those functions one by one. So data.loop, this is not data. In our case, this would be context, and we should already have the reference to it, and then loop. Yep. So this would be context.loop. How about this one? On stream change seems small. So so we can replace dot with context. Let's do the same thing. Pass in the reference. My bad. All of them can work the same way. Fix the data issue. This is all fine. Yeah. Okay. Apps. APS. Passing a string, but it is expecting a character set, so just call data on it, parse the internal data. What else? Okay. Oh, no errors. Okay, let's zoom this a bit and see what's happening. So we don't need this, so let's delete that. Okay, what's the problem with this? Okay, so before we do anything, let's add our own thing here. So we can, let's not do anything here. See out on. Okay. Oh, we haven't actually done anything about our start and stop. But before we do anything, let's see if it's building or not. Okay, see out is not a member. Are you stream? How about now? Okay. It does build. So syntactically we are correct. Let's start the stream and then stop the stream. Okay, so for that I will still go to our example file. Here we can see if you have copied till, I think let's see where we have copied till audio stream, and this is our context creation part, new simple. Yeah, so this is while we are creating this. So let's assume that this is the starting the stream part. So here we are starting the stream and we are running the stream. So obviously this should also be part of our start logic. So let's go there on start, on just start. Buffer is missing, so okay, then it's part of our creation logic. What are we doing with the buffer here? No, this is different buffer. This is the buffer. Pod builder. Right after props we have buffer. Something happened, man. Okay. Anyway, we need this. So this was supposed to be here, but it seems like that we are not using it anyway until we create the param. So we can safely move this part and its buffer dependency to our on start. Makes sense. So we'll start the buffer, we'll create the buffer जो हमें stream start ही करना होगा. So we'll start. Okay, next. Params also itself is missing. So what is params? Params is this. I'm assuming it is also being used only here. Oh, still I think something else. It's an array of size 1. Okay. How about data.stream? And our case data, there is no data, there is only context. And what else? Context.loop. Context is a pointer, so we need to use arrow. Let's build and run. On process is also being called already, I think, but we haven't called the end part. So at least this much part works. Let's work on the stopping the stream. It should be part of our main logic. Yeah, just this thing. So whenever you want to stop, we'll just do this, and should be context. Let's do it for everyone, man. Data context. Okay. Okay, I can actually hear audio being change a little bit when we start this. So basically probably हमारा माइक का इनपुट भी ले रहा होगा, तभी हमारा हेडसेट का वैल्यू चेंज होता है. What else? Now actually we can try to recreate that example where we are like, you know, showing that star sign, and let's remove this thing first on process and fix this part. So we'll have originally like recreate our example, but with CPP standard and also class and object, so which is better. What is the issue? Oh, does it work already? Testing. Oh yeah, it does pick up mic volume. So as you can see here, so this thing is moving around. Okay, cool. Time for a short break, and yeah, I'll come back to do the visualizations. This thing is not picking up our Google Chrome tab. Oh, because the name is wrong. It has to be capital C. So let's try this with capital C and see if it works. Better. So we have two channels left and right, and they are like reacting to the music. Okay, so what we have done, we have taken the example audio capture example from Pipewire. We change it into CPP compliant code using class and objects and everything, and yeah, we can also change the input. हमने input पहले जो mic था यहाँ, it seems like mic था, उसकी जगह हमने अब उसको Google Chrome का जो output है, which is like the audio playing right now, वो कर दिया है. Okay. Now next thing I would like to do is to actually render something and see if it works. So to do that, I think what I'm thinking is, let's just pass one of these values, or probably both of these peaks as part of float. I know this is not the frequency buffer, but just for now we'll try to we'll try to recreate this thing in GUI. And another problem with this is right now it's going to be all on single thread, which is controlled by the Pipewire library. We'll just हमारे UI कोड भी इसी के अंदर हम हैक इन करते हैं. लेट्स सी, बाद में हम अलग थ्रेड बनाएंगे UI का. Okay, so let's do this. Let's try to call this function first. Standard cout receive. Go to audio stream on process. We are printing. These are the channels, and peak values are here. Max. So peak is a max. So we need to return this per channel. Okay. Where's a for loop for channel? Yeah. So let's create a standard vector and of float. Call them peaks right now, and max, and okay. So I want to make sure that we should have a frequency callback called, which is a main function, and we should have two values in it. OStream, what the fuck is OStream? Main.cc, obviously forgot to IOStream. Yep, we are getting two frequencies, and now let's do some GUI thing. Okay, ChatGPT. Add Raylib to CMake project. Let's get the CMake configuration so that we can have Raylib here. Okay, so now go to our main.cc. Let's ask for a sample program where to just show window. So Raylib example to draw a window and a red rectangle. Hmm. Let's copy this entire thing and we'll pick and choose. What else? Yeah, we need this here and set target. That's fine. So yeah, regarding while loop, it's going to be handled by the underlying library. So just set up the initialization and closing. So we have initialized and we have closed, and whatever inside while you can assume is going to happen in the frequencies callback. Okay. And let's remove this. So okay, we don't see the window being drawn. Are there any other? CMake itself failed. CMake list. Some error. So yeah, we created the window and we got the frequencies, then we segfaulted. So we segfaulted here. Are we running on separate threads? Function to print thread ID in CPP. So it's you need thread and you need this function. Okay. So if you're on different threads, then it won't work. So yeah, and let's print thread ID here and print thread ID here. So initial ends in 128. Oh, so both of them ends in different numbers. So we are on different threads. Why? Okay, so the problem is we are initializing our window in this main thread, but what this thing audio stream class is doing is running this callback on an entirely different thread, even though we haven't created anything. So probably Pipewire internally is calling all the functions on a different thread. Okay, let's see how can we change that. So should be part of the stream setup code. Nothing relevant. Create a simple stream as a code and remote objects for you if you don't need to deal with them. The most important event you need to listen to is the process event where you need to produce the data. Okay, media key type audio config, nothing related to that. This is also fine. Uncommon to capture the same monitor ports. Now stream events. So here we are starting the stream. We specify the format, connecting the stream, input direction, PID any. Invalid items have any object which when used for permissions. Okay, doesn't seem relevant. Auto connect, MP, RT. This seems like the problem. Call process on the real-time thread. You must use RTC functions in the process. Okay. It seems like if you just remove this thing, it should work. Okay. Amazing. Okay, cool. Now let's actually draw that. So main.cc. Okay. So we need to draw the rectangle based on the amplitude. So let's get these values first, I think. So we'll use float peak one would be buffer dot at 0 and r2 at 1. Okay, so now let's draw rectangle, position x, positioner, width and height. So we need to modulate the width. So what was the values? Okay, it's just something which is less than 1. Let's assume 400 is the max and we multiply it by peak 1 and seeing 100x is correct. The height is 100, so we should be getting 300, so that there's some gap between them. And yeah, channel 1, channel 2 ready. How about now? Okay, if I try to close the window, it doesn't work. I have to end it via Control C. Yeah, okay. I think this is a good place to stop. अगली बार हमें I think thread separate करना पड़ेगा. UI thread और वो thread अलग होना चाहिए. And we also need to find individual frequencies of the audio so that हम थोड़ा अच्छा visualization create कर पाए, which is bend on individual frequencies, very similar to the visualizers we see. I think equalizer would be a good way to imagine. So yeah, I think it's good. So yeah, see you guys next time.